Good afternoon. My name is Usman Shakeel, and I'm a solutions architect with Amazon Web Services. Today I'm going to talk about pure play video over-the-top platforms, a microservices architecture in the cloud, and how do you build it in the AWS cloud. So obviously, we know that we've come a long way in the media business, and the business challenge has changed a lot on us. Gone are the days when there was a single experience that we had to worry about, that we had to deliver to say, a TV set over defined standards, manageable innovation, and hardware infrastructure. What we see in the future, the elusive target is a range of these set of devices that is millions of experiences, devices, delivery methods, content choices, and on top of that, more from a business perspective, faster time to market. Right? We're seeing that companies coming up with ideas, with concepts, with only a few people in their workforce, and innovating and getting acquired by other companies. So the idea with the speed to the market matters a lot. In addition to that, there is the software infrastructure that is at play, right? So there is a big difference in terms of what companies were forced to with earlier compared to where we are today. So in this particular talk, obviously I'm going to talk about over-the-top platforms. I'm not going to talk a lot about, say, the phrase like content is king. Rather, what I'm going to focus on in this talk is building an over-the-top platform from scratch in the cloud and using microservices. So first of all, a few clarifications. There is a whole lot of discussion around the differences between OTT, OVP, even the different flavors of video on demand like the AVOD, TVOD, and SVOD. But quite frankly, does it really matter? Right? If you look at from a design perspective, from an architecture perspective, the underlying principles are the same, which is actually delivery and scalable and highly available delivery of the content to your consumer. And then there is microservices, pure play, a bunch of buzzwords there. But I believe that microservices has a great play specifically in the workloads like over-the-top platforms. And specifically why? Because there are tasks within the over-the-top platform that can be specific scope, and that could be interoperable services that function individually on their own, completely independent, and can enable you to build a highly robust and scalable environment. And obviously, that also allows for a rapid innovation. So what is the over-the-top platform? Some of the components that are there, right? So starting with the content production aspect that includes, say, even from ingesting your mezzanine assets or raw assets to doing different processing tasks to it, to having it stored in a scalable manner, and then content distribution, and most importantly, content consumption. So we'll deep dive into individual pieces here for the over-the-top platform and how you can build each one of these components in the cloud using microservices architecture. So all of these components in today's world for digital over the top, you can use the shared IT services that include security, infrastructure, network, and operations. And on top of that, when you look at the AWS cloud, there are also managed video processing and delivery aspects from the partner ecosystem that Bhavik covered earlier, from a media-specific partner ecosystem perspective, as well as the new acquisition of Elemental. So very quickly, let me give you guys a recap of the different Elemental products that are sort of say relevant to this type of a workload. So as you can see in this chart here, from either from a file-based or live scenario, you'll see different aspects of Elemental product set, from Elemental Server, Elemental Conductor, Elemental Live, and Elemental StatMux that could be deployed on premises as well as in the cloud in the form of, say, also Elemental Delta to do various different aspects of the processing as well as just-in-time transcoding add insertions, etc., from a delivery aspect. And all that can be built or is running on the Elemental Cloud, which is built as a platform as a service on top of the scalable AWS cloud platform. So on the content delivery architectures front, I mean, there are obviously two main workloads, the live scenario as well as the VOD or catch-up scenario. So I'll quickly cover what are some of the architecture considerations in each case, and then we'll move on to individual tasks, if you will. So on the live side, we know that there is an RTMP ingest to the origin. Then there is the content is actually repackaged or encrypted on the fly for delivery. DRM is less common because obviously there is nothing that is being stored there. And then on the delivery front, there are different protocols like RTMP, and we're seeing a lot of sort of say investment into HTTP-based protocols like HLS, HDS, and Dash as well. But also like to mention that WebRTC is also something that is gathering some steam. And that's really a peer-to-peer network a protocol. But the idea there is that you can start with that, and then from there on scale up into HTTP-based protocols as well. On the VOD side, it's all file-based. You can store on an object store such as S3 or a CDN, such as where there is a storage provided on the CDN. Additionally, there is it's usually pre-prepared. That is, that you are pre-encoding, pre-packaging, DRM wrapping, and then storing it into a service like an S3 that can also act as an origin, and then you're doing simple delivery at the on demand. It's DRM by default because obviously it's all file-based, and depending on the mandates by the content owner or the content producer, you could have different DRM mechanisms that we'll talk about in deep detail. But in either of these cases, what we see is that ISPs are worried about more and more about unicast delivery, specifically in the case of digital. So let's take first the ingest and store piece, right? That is basically your content production as well as the content storage. So the problem that you'll have today, specifically on premises, is that you have an HD-SDI signal that's coming in. You may have a satellite transmission that you have to deal with. You have a pretty large-scale local SAN, which you are managing on premises, and you have hardware-based video transcoding or processing. In the OTT scenario, the approach will be, first of all, you want to have it all IP-based from ingestion perspective, and we'll talk about some of the solutions there. Or you will have FTP or some kind of an accelerator to transfer files. You'll have a large cloud NAS or an object store such as S3, and you can have an asset management system or a workflow system on top of it to actually do various tasks in the OTT workflow as well as the delivery aspects. So how does it look like? So I've tried to depict both scenarios, the file-based and say the live or baseband to IP conversion. So for a file-based, it's simply a matter of using, as I said before, FTP or some kind of an accelerator like Aspera, Signient, Eternity Cloudbeam, or even, believe it or not, the physical method, right? We just launched Amazon Snowball, which is a device that can be shipped to you, has 50 terabytes of capacity with a 10 gig network connection that you can connect to your on-premises. It squeezes all the content, highly secure, and shipped back to Amazon Web Services. And what you see, the next thing is that its content is available in S3. In addition to that, object stores like S3 also provide you a highly scalable front end capabilities. What that means is that you can quite literally just simply by using the interface that S3 provides you, parallelize the upload into S3 such that you can actually saturate the network bandwidth that is available to you. There is also AWS Direct Connect, which is a mechanism to connect to AWS directly over a 1 gig or a 10 gig or multiples of those. So the idea is that from a scale perspective, whether that be a few terabytes, a few hundred terabytes, or several of petabytes that you're trying to move to the cloud, it's a pretty easy or fair game. Then on the traditional mechanism where they say you have an HD-SDI signal or baseband, you will need to have it converted to IP, and that's where our newest member of our family, Elemental, comes into play, where you can have Elemental Live running on premises, doing the IP conversion, and then pushing it straight into the cloud. In addition to that, we have a pretty large ecosystem of partners like Hivision that build this solution, running on top of the AWS cloud, doing this IP conversion for you, and being able to ingest content into the cloud. The next piece is storage. So obviously, all this file-based or IP-converted files, they come in, they are stored into S3, the object store, right? Provides you highly available front end, as I mentioned, as well as durability at very cost-effective scale. In addition to S3 itself, you can also look at multiple different tiers within the object store that we offer. So there is S3 standard, which is providing you that durability and access to the content as you need. But at the same time, there is also S3 infrequent access. So what we notice is that for some of the files, like let's say your mezzanine asset files or assets or raw assets, where you're going to be processing that content or those assets once. You're not going to be retrieving that content for such a frequent manner. You can actually store it in a different tier called S3IA, which provides you the same durability, the same availability at a much cheaper cost in terms of storage. So S3 standard is, the pricing is retrieval or storage all built in, whereas S3IA, you pay a discounted price for storage, but you pay for retrieval as well. So in this kind of a model, for some of the files, you can use S3IA and save considerable amounts of money. Then there is the Amazon Glacier, which is actually the cold archive, sort of very similar to, say, your on-site or off-site archive that you have. In that scenario, it's even cheaper than S3IA for those long-term archives or assets that are not going to be used frequently. And the retrieval time, or SLA, there is between 3 to 5 hours. So we've seen cases where studios or media customers will keep a small portion of their content library inside of S3, which is readily accessible. Some other, another percentage of that, which is placed in S3 infrequent access because it's not frequently accessed. And then finally, the long tail type of content sitting in Glacier or archived in Glacier, but still available when needed. And the beauty of it is that from a storage perspective, it's a single interface that you can use to access all of that content. Doesn't matter where that content lives. In today's environment, if you look at on-premises, well, you have your online, you have your nearline or on-site, and you have your off-site. For every single system, you have a hierarchical storage management system, which is pretty complicated. Every single system has their own interface that you need to interface with in order to access that content. In this scenario, what we're talking about is a single API call, doesn't matter where the content lives, right? And then, on top of that, we also offer you S3 notifications. So, how would you say trigger a workflow today? You will have a watch folder where, say, you'll be watching if there is a content that lands in there. If a file comes in, then I need to start a particular workflow. So S3 gives you the capability to actually trigger a notification. Once a file lands in there, S3 will trigger a notification that can do a function, a job for you. And that's where AWS Lambda, one of our fastest growing services, comes into play. What Lambda really is, it's a piece of code. Just think of it as a Node.js code or a small script that lives in the cloud. You don't need to have any server running to execute that piece of code. Rather, it's executed on demand. And all you pay for is the amount of time, the microseconds or the milliseconds it takes or seconds that it takes for that piece of code to be executed. So just imagine, in a scenario where you have hundreds of files, thousands of files landing in your S3 bucket, you don't have any watch folder. Every single file can trigger a Lambda function and do a specific piece of function that's needed to be done for that, without the need of running a single server, a complicated workflow system, or anything like that. So from there, for example, let's say our file landed in S3. S3 triggered a notification that triggered a Lambda function. That Lambda function actually extracted some metadata from the file, which could be in the header, or it could be, say, text extraction by using some image processing algorithm or whatever have you. And then you can push it simply into Amazon DynamoDB. So DynamoDB is a managed NoSQL as a service, so key value store. You can have file names, author, title, the duration of the content, if it's HD, SD, whatever it is, all put in a key value store inside of DynamoDB. And from DynamoDB, then you can integrate it with Cloud Search, which is again our managed search as a service, and it'll index all your metadata that you put in DynamoDB now and make it available to you. So in a sense, where I'm getting at is from content ingest, metadata extraction, metadata population to search capability, it's a making of an asset management system of sorts, right? And what you see here is there is not even a single server in play. Then from there, the same Lambda function can actually take or call Elastic Transcoder, which is our managed transcoding as a service. We manage a fleet of transcoders. You don't have to worry about how many servers we run and whatnot. You just simply say, here's a file sitting in S3, go transcode it. This is my configuration for the transcoding, profile, etc. And this is the amount, this is the type of renditions that I need, if you need encryption with that, or if you need DRM wrapping, etc., all that stuff. Similarly, Elemental Cloud is also available through the API interface that could be triggered through Lambda. So the idea here is that this entire chain from metadata extraction, metadata population, from proxy thumbnail generation, from profiles, rendition, packaging, DRM wrapping, all that stuff can be triggered by these small microservices or Lambda functions, putting stuff back into one single object store that is S3. So great, I have metadata, I have the thumbnails, I have profiles, everything is nice there. How do I access it? That's where Amazon API Gateway comes into place. Now that's a managed API interface that can front Lambda functions and can actually call these Lambda functions on demand based on the requests. So just imagine if I have 100 users, some content editors, some channel playout folks, some QC folks, etc. They need to have access to different pieces of content, right? I can very easily build an interface that calls API Gateway that can actually trigger Lambda functions that will go fetch contents or call the search interface or make these queries from DynamoDB and make this content available to me. And since the proxies are available there, I can use Amazon CloudFront to deliver these proxies. So here, this is basically your content ingestion and your storage, or you could call it production as well, with asset management without any servers using microservices. The next step is processing, right? So in the case of processing, there is 3 main tasks. Maybe there are 4 or 5, but the main task, encoding, packaging, encryption. There is obviously QC, there may be versioning, mastering, and actually packaging in the supply chain. But if we focus on encoding, packaging, and encryption, in any case, what you'll see is there is multiple client devices that we're dealing with, right? So we talked about in the context of OTT, there's millions of devices out there, people watching content on their iPhones, Android devices, laptop, wherever have you. So, and how frequently new devices are coming into the market? Very frequently, right? So as a business, I am dealing with the challenge of having to transcode, encode, package, and encrypt the entire library for a particular resolution, for a particular device type, etc. And more content owners are focused on higher quality content. So we started with where SD, HD, ultra high def, 4K, 8K. And what we see is that with HDR, HEVC, the requirements, the compute requirements are astronomical. There's exponential increase in terms of the compute capacity that I'm going to need, the I/O performance that I'm going to need, right? And that's where cloud really shines. I can also run parallel complex workflows. So you don't have to worry about, okay, I have only one set of encoders on premises. hardware encoders on premises, I'm going to use the same for proxy canary creation. I'm going to use the same to create multiple different renditions or profiles, etc. Rather, you fork your workflow. Fork your workflow and use the underlying tool set which is applicable for the job. Earlier in the previous chart, I gave the example of using Elastic Transcoder to doing proxy creation, right? You don't need a lot of, say, professional quality stuff. You could do Elastic Transcoder, which is cheap, highly available, scalable to do these proxy generations. You need high quality profiles, renditions made, use Elemental. So basically one workflow forked into multiple aspects of it, depending on the feature set, depending on the job that you're trying to do. And then more importantly, it's highly uneven load distribution. So what we run into is, because in a natural scenario, you'll see these files being dropped in with undeterministically in many cases, right? So you have all of a sudden these peaks and valleys that you have to worry about, and an on-premises infrastructure does not cut the needs there. So how do we use Lambda or microservices to actually do some of these processing tasks? Very similar to what I talked about earlier, where content lands into your S3 bucket. Your S3 bucket triggers notifications for each individual file. That notification can trigger a Lambda function that can have Elastic Transcoder, Elemental, or a pretty rich ecosystem of services like Zencoder, Encoding.com, Harmonic, you name it. All of these partner solutions that are available either in AWS Marketplace or as a SaaS-based model. You can trigger those through the API constructs, directly through Lambda. And the output of all these, whether you're creating profiles, renditions, or you're doing packaging, it all lands into S3, which then can in turn trigger additional notifications and Lambda functions. And the result is that those Lambda functions will then update your asset management system, or let's say if you have a very simplistic managed DynamoDB key value store for an asset tag to the underlying profiles that you have created. Right? So again, here you see the workings of the entire workflow in microservices. Now, in the media space, there is a term about golden eyes and golden ears, right? That's very important. You run a lot of auto QC, but there's a lot of tasks that need to be done manually. You're going to have editors that are going to want to rerun a transcode because there were some issues with the quality, etc. How do you do all that? So the same Lambda function that is triggering or automating the workings of an Elastic Transcoder job or say an Elemental job can be called using the API gateway. Again, API gateway is a front end, can act as a front end to a Lambda function, right? So I can say I'm an editor, a content ID X, Y, and Z needs to be retranscoded because there was some issue with the profiles that I created. So the content editor can go in using API gateway, trigger the same Lambda function, they'll do the job, and the rest of the workflow flows. So the idea is that through these microservices, again, you're chaining this pretty complex workflow. So even more microservices in the processing. We experimented with this. So we have a working prototype, and actually some customers are looking at deploying it into production. But how do you run these video processing tasks in a containerized format? So Amazon launched EC2 container service, which is a managed container service. So basically the idea here will be through same sort of process set that I talked about earlier, file lands into S3. S3 then triggers a notification that calls a Lambda function. That Lambda function in this case is a manager, which actually slices your 4K content into smaller sort of say segments. And each container is then deployed using the bootstrap from a configuration of some kind. And basically, I should actually populate this as well. So on each Docker container that's running on an EC2 instance, you can have a processing task, whether that is, say, running a FFmpeg transcode, or it is doing some kind of a QC job or packaging, etc. And we have Elastic File System, and Bhavik pointed out about it earlier, which is a shared file system, completely managed, highly scalable. So there is no capacity constraints through the elastic file system. So you keep on growing it, it keeps on growing. And from a performance perspective, the performance scales linearly to the amount of storage you have. So let's say if you have a petabyte, that's the type of performance that you're going to get. And you can have multiple different clients accessing the same elastic file system or shared file system through an NFS client. So the idea there will be that each one of these containers are accessing the content through elastic file system, and then writing it back to elastic file system, each one of these containers working on an individual slice, processing it, and then you have a manager which stitches this content together, and finally you have a target which is an HEVC target. So in this way, you can actually use the underlying EC2 instance or the virtual server at its most effective capabilities, right? So let's say if you have a specific number of cores, right? Certain jobs are going to require a certain number of threads, certain number of cores, so while a single container, single EC2 instance is running a processing task like a transcode or encode, it can also be packaging some stuff at the same time. So that's the whole idea behind it. So what about packaging, right? So what we've seen is there is a trend, or we already know that everybody is moving towards HTTP because RTMP is very hard to scale. I won't go into the details of individual HTTP protocols for delivery as well, so like HLS, HDS, and what are some of the caveats for each, right? But I'll really focus on, I guess, the overall architecture and microservices here. So within packaging, there are two kinds. One is the pre-packaging, in which case you have your encoder encoding stuff, you have your packager packaging it into HTTP package like HLS or HDS for delivery, pushing it into an origin server, and then the player pulls the individual segments or requests those segments from the origin server. And the other process is the just-in-time packaging, where you have, say, for example, a live stream coming in, you can have an encoder sending it to the origin server and the player requesting those segments directly, and you can have live to VOD or live to file scenario, where then that origin is also writing it after packaging. So with Elemental, you can actually see that you can do pre-packaging directly using Elemental Stream, which gives you that capability. So you can have Elemental Stream or Elemental servers running in Elemental Cloud in a highly managed fashion, and basically leverage that for pre-packaging. And for just-in-time packaging, Elemental Delta is actually a great product, where not only it does just-in-time packaging, but it also gives you a whole lot of other capabilities, like from live to VOD, also for dynamic add insertions or add insertions, if you will. So some of these capabilities are very powerful. What about encryption and DRM? So mostly what we see is that it's still largely driven by the studio requirements because they are the content owners. Just-in-time encryption is pretty hard because even though there is a lot of advancement in the encryption side of the stuff, having it just in time, especially if you are trying to deliver at a global scale, becomes very hard because you don't have necessarily the compute capabilities at the edge. The good news is that there is also reusability across different packaging methods. So for example, you can use play-ready across HLS and smooth streaming. And on the AWS side, if you're using the cloud as a solution for, say, your OTT stuff, what you will see is that with Elemental, there is a pretty wide variety of DRM solutions that we support. So like Apple DRM on the HLS side, Microsoft play-ready for smooth streaming, other play-ready implementations, etc. Also Adobe DRM, MPEG-Dash, Common Encryption, and other DRMs. There's a whole lot of detail on the Elemental page. Some additional thoughts on this. So as I talked about, you have to look into what your content retrieval patterns are. If it is mezzanine files, how often you're retrieving your mezzanine files. If it is renditions, where are you storing the renditions? So even though the cloud offers you that object store, right? Within object store, there are multiple tiers that are for your benefit so that you can use the right tier to give you the most cost-effective, the most highly scalable performance that you're looking for specific to your workload, right? So, but the idea is that it makes the single API makes it very easy for you or your applications to be able to access all those objects. You should mix and match your encoding, as I talked about. use the tool that is appropriate for the task at hand. And then just-in-time packaging with heavy caching. So you can use just-in-time packaging like Delta I talked about, but you should put an attention towards heavy CDN caching. And also remember the 80-20 rule, right? That, or more 95-5, where 95% of the people actually watch 5% of the content, right? So that really defines which content should live in highly readily accessible storage like S3, and what should really go into your archive or S3 infrequent access. So let's move on to content distribution piece. Again, I'm not going to spend a whole lot of time here talking about the distribution protocols or HTTP-based protocols or flavors like HLS, Dash, HTS. Rather, I'm going to focus on multi-CDN strategy, right? Because I think that's one of the important aspects, and a lot of people actually do get puzzled by, I want to use multi-CDN, but how do I actually implement it? So there are a lot of sort of say methods out there or strategies out there for multi-CDN. You can do simply DNS based, which could be geo-focused. So let's say if you have a CDN which is strong in a particular part of the world or the globe, you can use that CDN over the other CDN. You can do latency based. So Amazon Route 53, our DNS service, provides you latency based routing capabilities. Or you can do some other intelligent routing at DNS level. Some kind of a business rule that you can put in there. Things like Sodexis offer you that kind of a solution. The other possibility is you could simply do asset sharding. You can say 50% of my assets are going to be served through CDN A, other 50% through CDN B, so on and so forth. Call it a day, right? But doing that intelligently at scale becomes a problem. And that's where CDN-aware asset information service becomes very common. And what I will do in the next few slides is to talk about a design pattern for a CDN-aware asset information service using microservices, right? So here you have your content consumer on the left-hand side that's requesting a piece of content. How would you do that? So let's say it's a web page, you have a player embedded in it, the player is going to request a piece of content, whether that's a manifest file or the individual segments. So it does that through a web front end, right? So that web front end I've tried to show here through an Elastic Beanstalk, AWS Elastic Beanstalk, which is a managed service that you can use for things like you can have a Tomcat server running, for example, in a managed fashion, or a web application. So there is some kind of a verification or authentication authorization happening here. And after that, that web app will deliver a URL to the player, and then the player goes and requests that content from the CDN, right? So here you can build in that intelligence where, as we talked about, the metadata is already here, from ingestion to processing in DynamoDB or your content management system. So that metadata can also include the information about if this content is requested, what is the CDN that's going to be delivering it? You can also put country codes in there which says, okay, if this content is requested from country or geography A, you send this URL. If it is being requested from geography B, you send this other URL, right? And this all can happen through the same asset management or asset information storage that you have in place. Now let's replace this Elastic Beanstalk with microservices like Lambda, right? So again, Lambda will be a function which is all it's doing is a query to your asset information system, and you put API gateway on top of it for high scalability. So let's say whether you have 100 users or 1 million users, you don't have to even worry about scaling your infrastructure. It's all managed, done for you by API gateway. And then each API gateway request will trigger a single Lambda function for each individual user request, which queries this information storage system and says, hey, I'm having a request for a particular piece of content. What is the URL to it? It is CDN A. This is the URL, go deliver. And your player can go fetch it. So things like these, microservices like implementations like these, take you a step forward. Where, sure, cloud is great, you can do auto scaling, you can do high availability and all those things. But in this case, you don't even have to worry about that. It's a step ahead of that, right? Because you are letting AWS to manage all this undifferentiated heavy lifting for you, where even this high availability concept and scalability concept is taken care of, and you're using a managed service. Lastly, let's talk about content consumption. So the problem really is imposed by the content owner again, right? Where the content owner says, we mandate on-stream concurrency, where I don't want me sharing a piece of content with 50 family members. I have a pretty large family. I don't care, I'll share some premium content episodes with them. How do the content owner make sure that I'm not sharing it with everyone, right? That at a given time I have 50 episodes of a pretty premium piece of content playing at any given time. So there are pretty standard approaches like player heartbeat and also subscription-based thresholds that are in practice. So let's talk about how would you implement that again in the cloud using microservices. So first of all, heartbeat is being sent from every single player at regular intervals. Let's say I'm watching a piece of content on my laptop, and the player will actually send in a piece of information. In this case, this is an example package, which is asset ID, my user ID, the timestamp that I'm watching, the device that I'm watching it on, and device type. In this case, say I'm watching it on Fire TV. So my player actually sends that over to the underlying system, and in this case, it's sending it to Amazon Kinesis. So Amazon Kinesis is a completely managed, highly scalable ingest as a service. So think about, you have millions of these requests coming in from each and every single player that is playing a piece of content. And even though it's a small payload, in the grand scheme of things, it all adds up. So the scale is there, it's completely managed, and it's durable, where we are storing the copy of that payload that you send, or that message that you send, for a period of time. So then that is tied into Kinesis, to Lambda as well, right? And what does that do? So Lambda actually takes this piece of snippet that came in, that piece of information that player sent in, and pushes it into, again, my key value store, DynamoDB, which is going to act as my subscriber manager. It's going to say, Usman is watching episode 1 of Breaking Bad, and it's at this timestamp. Now, if I share that with someone else, share my account information with someone else, with 5 other people in my family, it's going to stop it. Because what happens is, for every single segment, it's going to go contact the DRM server and going to say, hey, give me the license keys for me to be able to unencrypt this content, to be able to play it in the player. The DRM is going to say, no, there is already 4 people watching this on this account. 5th person cannot watch it. Sorry, permission denied. So that's how you can manage concurrency, how many people can watch a particular piece of content. Now, you can take it a step further, because I have the information as a content owner. I know who is watching what, because I'm getting that information at a highly scalable way from the players. I can put it into Amazon Redshift for historical analysis. I can find out what are the particular episodes that are highly popular. What are the pieces of content within a particular episode that some people didn't like, people across a different age group or a demographic did not like, and they kind of skipped through it. What are the pieces of content that people kind of rewind through, watch over and over again? Then I can tie it to Amazon machine learning. So since I have all that data now, you can tie it with Amazon machine learning to define these really cool patterns, which tell me that a particular piece of content was highly popular among a particular demographic, a particular age group, etc. And at the same time, since I have that's for the historical data set, and then I have the real-time data set through DynamoDB, I can also use that to do personalized ad insertions. Because I know who's watching what, which part of the content they liked, they skipped through, they watched over and over again, and based on that, I can define my personalized ad insertions. All right. Now, and one last application of it, and then we'll go to some real examples, right? So one of the other things that I like to do with the advent of this OTT, that I can watch my content in all these different devices, I'm watching a piece of content on my iPhone or on a piece of, on my TV. Now I'm in the train, I want to watch it on my tablet. I'm somewhere else, you know, in the meeting, I don't like the meeting, I want to watch that on a different device. How do I manage where I left off? How do I manage the sessions? Again, going back to the individual timestamp coming in, being stored inside of DynamoDB, I go log in through a different device. My player can, again, use API gateway as a front end to call and get that piece of information, which tells me this was the timestamp that I left off, and without anything, me doing anything, let's say if there's a cookie that's saved already, CloudFront can do cookie verification, etc. All that stuff happens behind the scenes in a highly secure way, and all as a consumer I know is the least amount of friction. I start watching the content where I left off. That's nice. So let's see over-the-top platforms in the cloud for real. Who's actually doing something? First example, BBC. So BBC launched this thing called the BBC iPlayer, and the back end of that is a system they built called Video Factory that actually captures live broadcast and sends it to Amazon S3. So they are actually using Elemental on premises that converts it, sends it over Direct Connect into S3. From S3, it actually goes into Elemental Cloud, where it's encoded and pre-packaged, and then send it over the CDNs and deliver to multiple different devices. The second one for live streaming workflow, we had a customer example with EBS, and this is specifically for the World Cup soccer or football, whatever you want to call it. So from the venue, 10 megabits per second live HLS input streams delivered from Rio to Dublin. Who does this live HLS on the venue? Elemental Live is actually doing that, sending it over dedicated fiber into S3, and then the Elemental Cloud actually picks up, processes it further, and then converts to 9 adaptive bitrate outputs, 2 thumbnails, and 1 RTMP feed, which is then sent out or actually delivered to different broadcasters, affiliates, as well as direct delivery, OTT delivery.